Let's take a look at some properties of limits of sequences that are very useful in order, well, when we're taking limits. Most of these properties, as a matter of fact, I think all of them, you will recognize because they're the same properties of limits that we've done before. So let's start off with the first one here. Notice that the limit as n goes to infinity of an, we're going to call L. We're going to say equals to L. And limit as n goes to infinity of bn equals k. Obviously, this assumes there's f of x and a g of x, such that the limit as, or f of x equals an for all n positive. And likewise, g of x would match up with b of n, like we talked about earlier. And the limit as x goes to infinity of f of x and g of x would go to L and k, which allows us to do this limit to begin with. So, staying with these n's, the limit as n goes to infinity of an plus or minus bn, that's the limit of both these guys, will be equal to L plus or minus k. It's probably no surprise because that's the exact same thing we saw with continuous functions when we first introduced the idea of limits very early in Calc 1. Now the second property, the limit as n goes to infinity of c times an, remember right here c is defined as a real number, is going to be equal to c times L. Again, this is the exact same sort of thing that we saw with the properties of limits with continuous functions back in Calc 1. Now, a third property, the limit as n goes to infinity of an times bn, is exactly what you would suspect. It's L times k. Again, because we're relating these discrete functions to that of a continuous function. And this last property here, take the limit as n goes to infinity of an over bn. This would be L over k. And just like I did with continuous functions, we have to specify for k non-zero. If k is 0, then obviously we have an issue there. So those are some very simple, some basic properties of limits of sequences that come in very useful when we're taking limits of sequences. You probably would have guessed every one of these if I were to simply ask you, hey, what is this limit going to be? You probably would figure it out very quickly just by falling back on what you already know from the properties of limits of continuous functions. So there should be no surprises here. We just had to state them, even though it may seem obvious. We really need to state these so that we can use them as we need to.